Hey guys, so today we're going to be looking at starting our new unit on quadratic equations. So if we look at this first page here, we can see on the left we have some examples of some quadratic functions, and on the right we have some examples of some quadratic equations. Okay, and then at the bottom here we're going to sort these ones here as either a quadratic function or quadratic equation. So first we got to know the difference between the two. So let's look at quadratic functions here first. So for a quadratic function, you can try to look at these and see how it might differ it from a quadratic equation. So if you want to pause the video and try, you can do that. But what each of these ones have here, if you notice, they all have a y, or f of x means the same as y, and they all have x's as well. Okay, so a quadratic function, it's going to have y, and it'll also have an x. Now if we look at the quadratic equations over here, you can see that all of these only have x's, there's no y's, there's no f of x, so there's only one variable in these. Okay, so again, quadratic functions, it's going to have a y or an f of x, and then quadratic equations, it's going to have an equals 0 or it's going to have x's. Those are going to mean the same thing. So this one has equals 0, and then this one only has x's. Now looking at the ones down here at the bottom, what I want you guys to do is I want you to pause the video and try to sort these either into a function or an equation. Okay, so the first one, that one there, it has f of x and it has x, so that's going to fall into this quadratic function category. So that is a function. The second one also has a y and x, so that is also a function. And then the last one, this one only has x's, x, x, so this is an equation. So in this first section of notes, what we're going to be doing is solving quadratic equations, and we're going to be doing that by means of graphing. So we're going to need to use our graphing calculator. We're going to graph it on that and then determine the answers as we'll see below here. So what it says here first is the x-intercepts of the graph of a function are the zeros of the function, the roots of the equation, or the solutions. So all of those things, I'm going to highlight them, all of those mean the same thing. Next it says a quadratic equation can have two distinct real roots, one real root, or no real root. So all that means is it can either have two answers, one answer, or it actually has no answers when we go to solve it. So what this looks like graphically, we'll draw a picture for each one. So I'll draw my axis here, got my x-axis and my y-axis. Now I'm just going to copy that and use that graph for my other two down below. Okay, so for two distinct real roots, that means it's going to have two solutions, we said, two roots to the equation, two zeros, or two x-intercepts. They all mean the same thing. So I'm going to draw a graph, and as long as it has two x-intercepts, that's what a graph would look like when you have two solutions. Okay, so on my graph, if I zoom in here, looking at the graph there, I can see this graph comes up, crosses once here, goes up, and then comes back, crosses there, and keeps going. So it's got 1, 2 x-intercepts, so two solutions. Same idea with this one, 1, 2. The next one, for one real root, we just have to draw a graph where it touches the x-axis only once. So that would look something like this, or this. So in both cases, it just touches at one spot. Okay, and then the last one, to get no real roots, that means it can never touch the x-axis, so that's going to be something like this, or something like this. So in both of these graphs, it never crosses the x-axis once, so there are no real roots, or no solutions, or no x-intercepts, or no zeros. Okay, so looking at the next thing here, it says solve by graphing method 1. So this is going to be our steps for how to solve, and we're going to do this example right here. So it says write the equation in standard form. That's going to be our first step. Now standard form, what standard form is, you may have seen this before. It's ax squared plus bx plus c equals 0. So all it is you want everything on one side and then equals 0 on the other side. So let's do that with this one here. Let's do that as our first step. So all I got to do to get rid of this negative 10, I got to add 10 to both sides. Okay, so step 1 is now complete. Step 2 says graph each function and use your calculator to determine the x-intercepts. So let's get out our calculator and we are going to graph this right here. Okay, so in our calculator we're going to type into y1 negative x squared plus 3x plus 10. So now we can pull out our calculator, we'll turn it on, go into y equals, and then we are going to type in this right here. Make sure you use a negative instead of the minus when it's a leading negative like that. It's got to be negative and then x squared. Now that we have our graph in, we can click graph to see the picture. So looking at the graph, I can see there is one x-intercept here and there's another x-intercept here. So this question actually has two solutions. So let's find those. In order to find those, we're going to click second trace. That'll get us to this calculate function. And then we're given a list of options. Now we want to find the solutions, which is also called the zeros. And the reason it's called a zero is because if I look at my graph, this happens, where it crosses here, happens at a height of 0. So we want to find the zeros. Okay, so we're going to click option number 2. And then it's going to say left bound. Okay, and on our graph, I can scroll left and right. So let's find this answer here first. So what you want to do, get about at the point at where it crosses. And when it says left bound, you're going to go to the left. So click to the left. This point is to the left of this point. You'll click enter. Then it says right bound. So you can go back to the crossing point, but we want to go now to the right. So go to the right a little bit. If you wanted to go further, you could, but it's just kind of a waste of time. Okay, so we're to the right of it. Then we can click enter. And then it's going to say guess. We just click enter one more time for it to approximate the answer of where it's crossing there. Okay, we got x equals negative 2. So let's write that down. And by the same process, we will find the other x-intercept. Scroll all the way to the right. Okay, get on the point, and then just go somewhere to the left of it, enter, somewhere to the right of it, enter, one more enter for it to guess. Okay, and we got x equals 5, so we can write that down too. So there's our solution for that one. The second method that we're going to do here is just below. I'm just going to move my calculator out of the way. So in method 2, it's almost the same steps as what we did here in method 1, but it's actually a little bit easier because it has a little bit less work. So in method 2, our first step, it says graph the left side of the equation as y1. and then we're going to graph the right side of the equation as y2 in our second step, and then we'll use our calculator just like what we did in method number 1. Okay, so the benefit of method number 2 is that I don't have to move, say, the 4 to the other side so that I have everything on one side and it equals 0. I can just graph this side, see where they cross, and then I get my answer. So I'm going to set y1 to be this left side here, and then I'm going to put in y2 as the right side, which was just a 4. Okay, so I can get my calculator back out. I'll go into y equals, we'll clear what we had, and then put in x squared minus 3x. Click enter to move down, and then for y2 we can put in a 4. And the order of these that I put them in, it doesn't matter. I could have put the 4 in the y1 and the x squared minus 3x in the y2. Okay, so now that we have that, we can click graph, see what we get for a picture. Okay, and I can see that it crosses here and here. Now with this method, what we do, we're going to again click second trace to get to the calculate function. It was no longer at a height of 0 though. What we want to find is where those two lines crossed or they intersected. Just like an intersection for roads, where you come to an intersection, it's where the roads cross. Same thing for lines. So we want to click option number 5. And then it's going to ask, are you on the first curve? You're going to move closer to the point at which it crosses. Click enter. Then I'll say, are you on the second curve? I can see now I'm on this straight line and get close to the point. Click enter. And then again, it'll ask you to guess. Just click enter one more time. Okay, and I got x equals -1. So let's write that. And then repeat the process for the other crossing or intersection point right there. So second, trace, number 5 is intersect. Move now closer to the right side to get that crossing point. So right there, enter. Now I'm on the other line, you can see. Click enter, and one more time. Okay, and we got x equals 4. So there are our two solutions. Okay, so we got one last example here, and with this one we could either choose method 1 or method 2. Now I think method 2 is going to be easier here because rather than moving all of one side to the other side or taking this stuff and moving it to this side, I can just graph this as y1, graph this as y2. Okay, and there's no need to simplify anything out over here. I can just take these and put those into my calculator. So let's get back out our calculator, go to y equals, we'll clear anything we had, and then y1, we're going to type this. And then y2, put this one. Now that we have both our graphs, we can click graph. Okay, and with this one, I can see I have one parabola going this way, so it's quadratic. So that was this first one. And then I had a second parabola coming like this, pointing down, and they do not touch in between here. So there's no intersection, there's no crossing point, which means there's no solutions or no answer to this problem. So let's write that down. Okay, so some questions can actually have no solution. That just means that there is no x that you can put into here that will make this side equal this side. So last problem we got here is an application question. It says a stone is thrown upward, its height h in meters, so the height is going to be represented by the variable h. After t seconds is represented by this function. So t is going to be time, seconds, h is height. This is our function that's going to be important. So the question asks, when is the stone at a height of 15 meters above the ground to the nearest tenth? Okay, so what this function means is that when I put a t in here, which was time in seconds, so let's say we put in 2 seconds, and I go 20 times 2 seconds minus 5 times 2 seconds squared, I'm going to get out a value. That value that I get out is just the height. The height is whatever I get. Okay, so if I want to find when the stone is at a height of 15 meters, it's telling me that the height, or h, is 15 meters. So if I know that the height is 15 meters, I just have to replace the height with 15 meters. Okay, and now that I have this equation, now I can solve this graphically using either method 1 or method 2, which we just did on the previous page. Again, I'm going to use method 2 because I find it a little simpler. So I am going to pick y1 to be this first side, 15, and then y2 is going to be my other side, 20t minus 5t squared. Okay, and then I'll graph those, see where they cross. That'll give me my solution. So back to the calculator, y equals, clear anything, and then we're going to type in our two functions. Now notice when I type that in our function we had t here. Okay, when I typed it in though, the only thing I can use is this x button. Okay, so although it's an x, it doesn't really matter. It's just a variable. The calculator can still find the solution. It's just using a different letter to represent the variable. Okay, so let's graph those and see what we get. So when we graph that, I can see we got the parabola. That's this quadratic. Okay, but we did not get y equals 15. Okay, and this is just going to be a horizontal line at the height of 15. So the current window I'm at, it's just the standard window where it's 10 up, 10 to the right, 10 units down, and 10 units to the left. So I can't see 15 up. What I got to do is go to my window, and I'm going to make the max for the y go up to at least 15. I'm going to go a little bit more so that I can see my whole graph. So I'm going to set it to 20, go back to my graph. So I can see it's a lot higher now. So now I have this line and I have the parabola, and I can see where they cross. So I can go second, trace. So I want to find where they intersect, so that's number 5. And then go closer to the point you're trying to find, and then you can click enter, 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 and it'll find the closest one there. So x equals 1. And then finding our other one, second, trace, number 5, move over to the other point, and then enter, enter, enter. And we get 3. So that's our solution for that one. Okay, our homework that we're going to be doing, I'll just write down below here. So interpreting now what this actually what this answer means to us, we had said before so interpreting now what this oh my god, man. So interpreting now what this answer here actually means to us, we said that the t, oh, and that should be a t, let me just fix that. the t that we just solved for, t stood for seconds. It was the amount of time. So this answer of 1 and 3, it stands for 1 and 3 seconds. So at 1 second, it was at a height of 15 meters, and also at 3 seconds, it was at a height of 15 meters. This is because as a rock is thrown up, it's going to go up, reach that height of 15 meters. That happens at 1 second, continues up, then it starts to come back down. At 3 seconds again, it's at a height of 15 meters, and then it falls down to the ground. Okay, so 1 second and 3 seconds. Now our textbook questions that we're going to be working on, I'm just going to put them down here at the bottom. So we got page 402, numbers 2 to 4. I'll move that out of the way. And we also got 7, 9, 10, and 12.